Hello everyone. In this video, we will discuss a theorem which is related to triangles. It says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio, which means we are given a triangle ABC and this line DE is parallel to BC, and this line intersects the other two sides of the triangle, that is AB and AC, at points D and E. We are required to prove that these other two sides are divided in the same ratio, which means AD by DB is equals to AE by EC. So let's find out. Now we are given with the triangle ABC where line DE is parallel to line BC, and this line intersects the side AB at point D and side AC at point E. Now we are required to prove that AD by DB is equals to AE by EC. For that, we need to do some constructions. First of all, we will join BE and CD, and we will draw a perpendicular DM to the side AC and a perpendicular EN to the side AB. Now let's look at the proof. First of all, we will consider the triangles ADE and triangle BDE. We will find their areas first. So the area of triangle ADE will be given by half into base into height. Its base would be given by AD and its height is the perpendicular, which is EN. Hence area would be given by half into AD into EN, and we mark this equation as equation number 1. Similarly, for the triangle BDE, area would be half into base into height. Its base is DB and its height would be the perpendicular, which is EN. Hence the area of BDE is given by half into DB into EN, and we mark this equation as equation number 2. Now for further simplification, if we divide both these areas, we will get half into AD into EN divided by half into DB into EN. Half EN gets cancelled out from both the areas, so we are left with AD and DB. Hence, we obtain AD by DB, and we mark this equation as equation number A. Now similarly, we will find out the areas of the triangle ADE and the triangle DEC. So the area for the triangle ADE will be given as half into base into height. Earlier, we had considered AD as our base and EN as our height, but this time we will consider AE as our base and DM as our height. So the area would be given by half into AE into DM, and we mark this equation as equation number 3. Now if we look at the triangle DEC, area would be half into base into height. Here the base would be given by EC and its height would be given by DM. So we get half into EC into DM, and we mark this equation as equation number 4. For further simplification, if we divide both the areas, we will get half into AE into DM by half into EC into DM. Half into DM gets cancelled out in the both areas, so we are left with AE by EC, and we mark this equation as equation number B. Now we know that if two triangles share the same bases and are between the same parallels, then the area is equal. Hence we can say the triangle BDE and triangle DEC, they share the same base, that is DE, and they are also between the same parallels, that is BC and DE. Hence we can say the area of both these triangles are equal. Further, we can write area of ADE by area of BDE is equals to area of ADE by area of DEC, which we just found out. So by putting the values from A and B, we will get AD by DB is equals to AE by EC. Hence, proved. This is what we call as basic proportionality theorem, which says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in the distinct points, then the other two sides are in the same ratio, which is AD by DB is equals to AE by EC. Now let us perform an activity which is based on converse of this theorem. So the activity is based on converse of the basic proportionality theorem. Now we have this angle XAY. We have drawn a ray AX and we have marked these points such that these points are equidistant from each other. So AB1 is equals to B1 B2 is equals to B2 B3 is equals to B3 B4 is equals to B4 B. Similarly, on the ray AY, we have marked these points such that AC1 is equals to C1 C2 is equals to C2 C3 is equals to C3 C4 is equals to C4 C. Now we have joined B1 C1 and BC. Now we observe that AB by B1 B is equals to AC by C1 C. Why these are equal? Because these form a part that is 1 by 4. Here you may observe that between B1 and B we have these 3 points which have divided B1 and B into 4 equal parts. Similarly, between C1 and C, these are the 3 points which have divided C1 and C into 4 equal parts. So we can say that these both form the parts 1 by 4. And we also found out that B1C1 is parallel to BC. And we mark this as equation number 1. Similarly, by joining all these lines, we will obtain the similar results. For example, if we join our first line, we will get AB2 by B2B is equals to AC2 by C2C, which is equals to 2 by 3, and we will also obtain that B2C2 is parallel to BC, and we mark this equation as equation number 2. Here you may observe that AC2 and AB2 are given as 2 because between A and B2 we have the point B1 which has divided A and B2 into the 2 equal parts. Similarly, between A and C2 we have C1 and it has divided A and C2 between 2 equal parts. Similarly, between B2 and B we have 2 parts which have divided B and B2 into 3 equal parts. Similarly, between C2 and C we have 2 points C3 and C4 and it has divided C2 and C into 3 equal parts. So we can say it as 2 by 3. And we also noted that B2 C2 is equals to BC. Now similarly, by joining the points B2 C2, B3 C3 and B4 C4, we will obtain our following results. Now using the results, we will prove the converse of basic proportionality theorem. Now from all the equations we get, if a line divides 2 sides of a triangle in the same ratio, then the line is parallel to the third side. This is what we know as converse of basic proportionality theorem. Now we have learned that basic proportionality theorem says that if a line is drawn parallel to one side of a triangle to intersect the 2 other sides in distinct points, the other 2 sides are divided in the same ratio. We also learned the converse of basic proportionality theorem, which says if a line divides any 2 sides of a triangle in the same ratio, then the line is parallel to the third side. Thank you so much for watching.